Hello everyone and welcome to this presentation. It's a pleasure to be part of this great community and attend the 30th edition of the EAI International Conference. This work has been supervised by Tiguiane Yélémou and will be presented by myself, Achille, student at Boni University. The agenda is structured as follows. We have an introduction. Then we talk about some limitation of SDN-WISE, followed by the objective of our study. We also briefly review some related work before proposing a new approach. Several analytics results will be displayed, and finally, we are going to close this presentation. So, SDN is an architectural solution that is currently revolutionizing the wireless sensor network domain due to its potentials. Indeed, it separates the control plane from the data plane of the sensor node and allows centralized management of the whole network. Nowadays, SDWSN are used in several application areas such as military, environmental, industrial, medical, and so on. And one of the SDWSN solutions, called SDN-WISE, will be the subject of the next slide. So, SDN-WISE is a framework that leads to further research for its improvement. It operates in two modes that are based on match check in the WISE flow table. When there is a match, the packet coming into the node is processed. Otherwise, it's queued for instruction and the node sends a flow rule request to the controller. However, this way of processing leads us to wonder what to do if other flow requests for the same source destination address are sent to the controller. That would probably lead to duplicate requests. Also, we would like to know how to deal with queued packet if the buffer becomes overloaded. That will create congestion problem to the node. So, we can say SDN-WISE highly consume energy due to both duplicate requests and node congestion, which could affect the quality of service. Thus, our general objective is to minimize the energy consumption of the node, but more precisely, we intend to implement a system that allows the management of node congestion and reduces the number of requests sent to the controller. It should be noted that researches aiming to reduce energy consumption in the SDN-WISE framework has been carried out in the past, and some of them can be illustrated by this table out there. So we come up with a new approach that tends to overcome the shortcomings of SDN-WISE by adding some parameters to the report message that is passively sent to the controller. Let's say in the CMFR-CMQ algorithm, the controller first determines the state of the node by calculating its congestion rate thanks to the information obtained from the report message. Thus, it can judge whether or not a node can be involved in packet routing activities. If the node is congested, then it can only receive flow rule for free its buffer. Otherwise, it can receive data packets for routing purpose. In this second case, the node proceeds as in SDN-WISE, except that here there is a mechanism that will limit the production of duplicate requests toward the controller. Now, To test the performance of this solution, we performed a comparative study with SDN-WISE and another solution called CMFR-CMQ. For this purpose, we made some hypotheses out there. The study focuses on 3 sensor nodes, ABC. The buffer of the node can only hold 5 packets. This experimentation is done in a context where a node sends a request message to the controller when it has not yet received a response for the source destination pairs concerned by the received packet. Initially, the controller commands a node A to send its data packet 20 through the node B, and finally a node is declared congested if its occupancy rate is greater or equal than to 80% of its capacity. The 2 figures show the data packet processing in SDN-WISE and CMFR-CMQ. In SDN-WISE, we notice that as long as node B has no instruction for a given packet type, it will continue to store these packets until its buffer becomes full, and at the same time, it will send the same number of requests to the controller as it has packet stored. A similar case can be observed in CMFR-CMQ, except that it will only send 1 request to the controller for the same type of packet, source destination. Finally, the last figure is for the CMFR-CMQ. It proceeds as CMQ until its congestion rates reach 80%. Once this level is reached, the controller connects nodes A and C, just because node C is available with a congestion rate below the threshold. Thus, node B will be able to receive flow rule to unload its buffer gradually. We plotted the statistical result of this study according to the packet stored, the packets lost, the request produced, the rate of packet loss due to congestion. And here we can see that theoretically CMFR-CMQ has obtained better results. So to summarize, we have seen the CMFR-CMQ algorithm, which allows both to reduce the number of flow rule requests and to avoid the congestion of the node due to the queue packets waiting for the controller routing instructions. And we think that really this system might optimize energy consumption and increase network lifetime, minimize the number of request messages to reduce the rate of packet loss, and to balance the load of the network. So as a future work, we are planning to implement in a simulator and test the proposed approach based on real statistics. Here are our key references and so on. That put an end to this presentation. I would like to thank you for viewing. Question?